This is 1.2, which is about finding angles. Here are our objectives. We're going to learn about angles and the notation and measurements, um, things like that. Talk about congruent angles. Um, yeah, and actually, so we'll go through those. Some vocab. Okay, so an angle is two rays that have a common endpoint. So here we have ray OA and OB, and they have the common endpoint of O. So in angles, when we talk about angles, we need to make sure that we have the correct terminology. So O is the vertex, which is the endpoint that the two rays share. And then the other rays are called the sides. So ray OA is a side and ray OB is a side. And lots of times when we see angles, we don't mark them with the ray going on forever, but they are there. That's part of what we talk about. That green section there is the interior points, and outside of this would all be our exterior points. So interior is in between the rays and exterior is on the outside. Okay, there are three different ways to name three different ways to name angles. So I can use three letters. So in this case, we have angle AOB. And then I could also, if I wanted, do angle, that's terrible. I could do angle BOA. So that is really the same way. Okay. So that using three letters. And the big thing here is that the vertex has to be in the middle. So I've taken a point from each of the rays, and then the vertex is in the middle. So either one of those is okay. You could also just call it by the vertex. So we can call this angle O. The trick here, though, is that you can only use the vertex alone if it's one angle by itself. And we'll see an example of that in a little bit where it's not, and so where that would not be okay. The other option is to use a number. So in this case, there's a 1 in between, so we can call that angle 1. Lots of times, this makes things much easier. If you come across a diagram where it's only labeled with letters, you may put numbers in there to call it by the number, and it will make things easier. I also want to point out that we have this mark, right? So when we say an angle, when we write it, the notation is to use that angle symbol and then whatever we're using to name it. Okay, and that means the figure as opposed to a measurement. When we just have an angle like that, it means the figure. Okay, so I would like you to name this angle and see how many different ways you can name it. So one way we can name it is we can say that this is angle 4. We could also say this is angle C. And another way would be angle ACD. We could say angle DCA. I could also say angle BCD or angle DCB. So notice there are many ways to name that angle. I have my number way, which is angle 4. I have the one letter vertex angle C, because at angle C, there's only one angle. I mean, at vertex C, there's only one angle. And then my other 4 names are really, there's 3 letters, And notice with each one, the vertex is in the middle. That's really important. C is always in the middle for this angle. Okay, go ahead and try to name that angle. Okay, so here we can still go with the number here. We can call that angle 3. Or I can do angle BDC or angle CDB. And that's it. I cannot call this angle angle D because there are 3 different angles at vertex D. There's angle 2, there's angle 3, and then there's angle ADC. So let's see, we've got this angle and this angle, and then that angle. So there are 3 different angles at vertex D. So I can no longer just call that angle using the 1 letter. I have to use 3 letters. Or the number if it works where it is. In this case, it does. If I was doing the one that I highlighted in yellow there, I couldn't use the number. So the big thing here is that when we talk about an angle by default, we use the smallest amount of rotation. And if we mean the opposite of that, if we don't mean the smallest, we have to indicate it. So if we take a look at this angle that they've drawn down here, the default measure would be 136 because that's the smaller amount of rotation. And if I specifically wanted the larger one, then I would have to ask for the reflex angle or draw it. So one way I might do that is if I had this picture, then to indicate that I wanted the larger measure, I could do that. And then you would say it was 224, okay? And a reflex angle is one that often you maybe have not heard of. So a reflex angle is larger than 180 degrees and less than 360. That's a reflex angle. Okay, and these are all probably words that you are familiar with. An acute angle is less than 90. A right angle is exactly 90. Obtuse is greater than 90 and less than 180. Lots of times people miss that part of the definition. With an obtuse angle, it's important that we have those 2 boundaries, right? So it's greater than 90, but it's also less than 180. And then a straight angle is a straight line, and it's exactly 180 degrees. Okay, so congruent angles are angles that are the same. And here, a couple things that we want to point out. We've got this thing here. And just like in a line segment, that letter, that M in front of it means measure. Okay, so when I have M angle ABC, it means the measure of angle ABC. So we're talking about, for our situation, degrees. In when you're doing other things, if you're familiar with radians, that's another way that we can measure angles. But for our purposes, mostly we'll be doing degrees. So that M indicates a number that we're looking for, the measure of the angle, whereas the angle by itself means the figure. So again, measures are equal and figures are congruent. Okay, that equals with a squiggly line is congruent. And on the figure, we mark congruence in 2 ways. So there's this thing over here where we do these arcs, okay, and another, just show you again, if these 2 angles are congruent, then I can put 2 arcs as well. Let's see if I can move that. I'll put it underneath. So we could put 2 arcs there. The same number of arcs indicates that the 2 angles are congruent. If they have the same number of arcs, then those 2 are congruent. If they have different number of arcs, then they have different measures, different sizes. And then we can also use a tick mark. So in these angles down here, there is the tick mark inside, and they have the same number of tick marks, which indicates that they are congruent. Okay, and an angle bisector is very similar to a segment bisector. It cuts the angle in half. So ray DB is an angle bisector of angle ADC, which means that those two smaller angles have to be congruent, which is indicated by those arcs. And then we can also write that. We would say angle ADB is congruent to angle BDC. So if I've been told that DB is an angle bisector, then I can conclude that those two angles are congruent. And that's a really important concept for us. So we are going to be defending ourselves and really giving reasons, and we need to be specific about it. So if we know that something is an angle bisector, it means those two angles that it created by cutting it in half have to be equal. Okay, so I would like you to take a look at this and look at the pictures. Remember, you have to go by what's marked on there. You can't make assumptions, and you have to pay attention to the details that are in there. And I want you to determine which ones are angle bisectors, or one, or none. Okay, so in this first picture, we notice that those two angles, 44 degrees and 43 degrees, those are close, but they are not equal, so there is no bisecting happening in that angle. If we take a look at this one in the middle, then we've got 52 and 52. So we can say that ray RP bisects, that says bisects, angle SRQ. Okay, and it creates two congruent angles, SRP and PRQ. And then if we take a look at the last one, we have those congruent marks. And so I know that angle M, Y, M, N is congruent to angle OME. I know that those are congruent, but because there's that space in the middle, there is not an angle bisector happening there. That little space there makes it so it's not an angle bisector. I've got two congruent angles, but it's not one whole thing that was cut in half. So there's no angle bisector in that last picture. Okay. Angle addition postulate is very similar to our segment addition postulate, where we have a small piece plus a small piece equals the whole piece, as long as they're next to each other. So that green section plus the blue section equals the red section. Notice that AOX and XOB, they share a common ray. The ray that they share is OX. Okay, and that's important when we're talking about angle addition. They have to be right next to each other like that. So they have to share a common ray. Okay, I'd like you to take a moment to read this problem and try to solve it. All right, so we have a piece of pizza, and let's draw our slice. That's not even close to 140. Okay. There. So there is our slice of pizza, I guess. There we go. Which measures 140 degrees. And our friend comes along and she slices through the vertex to make two slices, and one of those slices seriously, that's terrible. Let's put that over here. Is 60 degrees. So you need to figure out what the other side of the other slice of pizza is. So we could just do 140 minus 60 gives us 80. So that would be 80 degrees. And really what we're doing there is using the angle addition postulate. What does it mean when we say two angles are congruent? So congruent angles mean that they have the same measurement. So they're the same number of degrees. It doesn't matter how they're oriented. So I can do a 90-degree angle like that and a 90-degree angle like that. And those two angles are congruent. Okay. And just, I'm not sure I've talked about this yet, but this symbol here is what we use to show that an angle is 90 degrees. Okay, last example for this, I would like you to find the measure of RTX. So what we can do here is we have all together, these make a circle. Right, so I've got this circle that happens. So I know that 135 plus 120 is 255, and then 255 plus 62 gives me 317. And then I'm looking for the missing piece to make 360. So this angle is 43 degrees. There's my work. Sorry, I'll explain this again. So basically what I did is I added up those three angles that were given to get 317. And then I took 360 minus 317 to get the missing angle that's there to give me 43 degrees. Once I have that, I want to know what RTX is, which is RTX. So I'm looking for this angle. And to get that, I'm going to just do 43 plus 120 to get 163 degrees. And that's using my angle addition postulate because those two things are next to each other, so I can add them together to get the full measure. Make sure when you're doing stuff, you remember to put your degree symbol on. Please make sure you show your work. And we want to get in the habit of being kind of meticulous about using units, using congruence, and being really careful about how we're working.